We're moving on, 11B. We're going to take what we did in 11A and we're going to extend it out a little bit. So if you need a refresher on what we did in 11A on simplifying the rational expressions, looking for common factors, so that we could use the clever 1 to cancel top and bottom, or the clever -1, then you need to go back and look at 11A real quick. So we're actually going to practice multiplying and dividing these rational expressions. And you might remember that division, when you're dividing fractions, you make it a multiplication problem by keep, change, flip. I think some teachers taught it that way. And we'll work with that as we go along. So the first thing you're gonna do is factor all of your polynomials individually and completely, without regard to anything else, any other polynomial that's in your problem. Take them one at a time and factor them completely. Then we're gonna rewrite with a single fraction bar, and we're gonna cancel all of our clever 1s. And then we're gonna multiply and put it all back together again and see what simplification we can do. So let me give you an example. Anytime you have a polynomial with no denominator, of course it's the understood 1. And I'm going to write it like that. So I am going to look at 4a plus 8, and I know I can factor. 4 comes out of both of those terms, and I have 4a plus 4 times a plus 2. The second factor in the numerator, I'm going to put parentheses around him. I don't want that a and that -1 to get separated. They go together. In the denominator, there's 1. I don't have to write him. 3a plus 6, I can factor a 3, and I end up with a plus 2. So now we've got all factors in the numerator and the denominator, and we're looking for what will cancel out and make the clever 1. So a plus 2, a plus 2. Do we have anything else? I don't think so. So it's just 4 times a minus 1 all over 3. And again, you don't have to multiply this 4 and make it 4a minus 4. This is considered simplified. Let's look at the second example. Again, I've got 4 separate factors I'm dealing with here, and I'm going to deal with them individually, and I'm going to make a single fraction bar, but I'm going to look at them individually. So x squared minus 9. I hope you recognize this as the difference of 2 squares. It's going to be important that you look for that always, first and foremost. And then x squared, I see some x's on the bottom. I'm just going to go ahead and write it x times x and see what happens in the bottom here. And then x squared minus 4x, again, I can cancel, I can factor out a common factor of x, and I end up with x minus 4. And 3 minus x doesn't have any common factors, so he just lines up again with parentheses around him. So now I have all factors, numerator and denominator, and I'm looking for clever 1s. So I have an x to the first here and an x to the first here. Those will cancel. I don't have an x plus 3 down here, but I do have these two that are opposites of each other. This one is minus 3, this one is plus 3. This one is plus x, this is minus x. And you might remember from last time, we can cancel these, but instead of making a clever 1, it makes a clever -1. So when I go write this and put this back together, this negative sign comes out to the front. Now you can put them with the numerator, or you can put them with the denominator, which looks a little bit weird, but most often you'll just see him in front of the fraction. It has to go one of those 3 places, numerator, denominator, or out in front, but not more than one, because that would of course turn it positive. So my answer, and I'm going to write this single x, and then the x plus 3 second, that's what's left in the numerator, and then the denominator, x minus 4 is left. At this point, it doesn't matter whether you put parentheses around that x minus 4, but to me this looks cleaner than without it. Okay, let's go do a couple division ones. So they're just exactly like the ones that we just did, except for you've got to remember that you have to make this a multiplication problem. It's starting as a division problem. In order to do that, you are going to, and I'll just do this one time showing you the multiplication, you are going to flip the denominator. Now we're ready to multiply, factor and multiply just like we did up above. So I'm going to put parentheses around these guys. And I'm going to look for a single fraction bar, and I'm looking for common factors. 5, and then that'll become t minus 2. And then the 2's just hanging out right there. This is t minus 5. Can't do anything with him, no common factors. On this one, the 8, this is times 8, and it's t minus 2. So we need to order this better. Usually, almost always, your numbers, your coefficients come first, and your variable terms come second or come last. So if I'm seeing this, I'm seeing that the 8 and the 2 have a common factor. So I'm just going to go ahead and move this 2 to the front. And I'm going to move the 8 to the front and write it as 4 times 2. And then in the denominator, I've got t minus 5 and t minus 2. So we're not done yet, but now we've set ourselves up that we can cancel our clever ones. There's one, and this one, and that one. So our answer, our final answer, our simplified answer becomes 5 in the numerator and 4 t minus 5 in the denominator. All right, one more on this page, then we're done. Again, we're going to make this a multiplication problem, but I'm going to go ahead and factor at the same time as I'm flipping, save a little space and a little time. So I'm looking at this first factor right here. I see that I can factor out a 2a. That becomes 2a plus 3. And in the denominator of my first fraction, I can factor out a y to the first power, and I get y minus x. I'm going to make this a multiplication problem. Now, in the numerator, I have x squared minus xy, and I can factor out an x. And in the new denominator, I can factor out a 3a squared. So I have left 2a plus 3. Okay, I need a single fraction bar, and I got to figure out what I'm going to do here. All of these two-term polynomials, I'm moving to the back end. I'm moving my 2 and my a and my x to the front. So 2ax, 2a plus 3 times x minus y. Same thing in the denominator. I have 3 times a, there's the a squared, times y minus x times 2a plus 3. This just makes it easier for me to see what I can cancel. If you skip this step, I hope you can do it accurately. That cancels, clever 1. That cancels, clever 1. And we have a clever negative 1 with x minus y and y minus x. So that will cancel, but we have the clever negative 1 in our final answer. So the final answer is going to be negative. He's going to just come down and hang out in front of the problem. What do I have left in the numerator? 2x. In the denominator, I have left 3ay. And that is the answer. Kind of a long fraction bar for what's left. Not much. Okay, see you in class.